right, welcome everybody. Happy 1st of May. It's hard to believe that we're already in May. Where does the time go? I say that partly in the context of the actual seasonal considerations that we'll be talking about today, but also just as a figure of speech. It is hard to believe, though, that it's May in the sense that we're already seeing some very early signs of a rapid transition between states in the atmosphere from El Nino to La Nina conditions. I'll talk more about that in a moment. And let me just transfer over to the right screen for monitoring this feed. All right, well today, as I mentioned, not quite a pop-up session because I'm not necessarily talking about live real-time weather events, but a little bit of a short notice session. So glad to see folks have made it. As always, it'll be recorded after the fact. I wanted to briefly discuss a late season weather system that looks like it's going to be a little more substantive than initially suggested by some of the models coming in this weekend in Northern California. It won't really affect Southern California, but certainly will bring a big change to Northern California. I'll talk about that for 5 or 10 minutes. It's nothing extreme or record-breaking, but it's notable given the time of year. And then I'm going to spend the rest of the session talking a little bit more about the transition from El Nino conditions in the tropical Pacific to La Nina conditions that's unfolding right now, and what that might mean for California and the West, and more broadly for the two different kinds of hazards in North America over the next 3 to 6 months. Wildfires, which are relevant primarily, although not exclusively, in the western U.S., and hurricanes, which are relevant primarily along the Gulf Coast and eastern seaboard of the U.S. El Nino, La Nina transitions tend to be consequential for both of these things, but especially in the context of a warming world. And we're seeing this shift unfold amid a backdrop of conditions that have never been warmer in recorded human history, and that does affect the interpretation. We can't just use our regular old analogs from the 20th century to tell us what's likely to happen. So that's the overview of what I'd like to discuss today. And just to give some indication of what might be coming down the pike, there will probably be an update with the seasonal predictions from the major modeling centers a little over a week from now. So probably not next week's office hour, but the week after that. I'll try and cover those updates because now that we're in May, despite my disbelief about how late we are in the calendar year already, that is when we might start to see some stronger signals in the seasonal predictive ensembles, at least where the skill starts to improve in some of these historical assessments of seasonal prediction model skill. I would say that this year we already have some pretty strong signals from those two things that I just mentioned. This pronounced transition between El Nino and La Nina and the backdrop of record global warmth, but it will be interesting to see if the model update cycle that comes out usually around the 10th of the month, so probably about 10 days or so from now, whether that changes the picture at all or reinforces some of what I'm going to talk about today. So the second part of this may be viewed as a bit of an extension of last week's conversation surrounding how upcoming conditions might affect wildfire risk in Western North America. So first, I want to just dive in, and I'm going to share my screen because that's usually of the most interest to folks in these initial stages. There is not currently, it's not quite what I wanted to show, but I'll get back to that in a moment. At the moment, there's nothing to show on satellite because the system is still pretty far offshore. It's still Wednesday. This probably won't get here till the weekend, so no live satellite tour today. But what I do want to show is the projected progression of this system into the weekend. It's going to be a pretty cold one. We are in May, so to see meaningful snowfall in the Sierra is certainly not unheard of, but it becomes a little more unusual as we get into May, and there probably will be some this weekend up at higher elevations, not a super low snow event by any means. And I just realized that my microphone may be in the wrong position. Let me quickly rectify that. It's possible that the audio volume is very low, so let me address that right now. That just slipped my mind, transitioning between meetings, transitioning between two different sets of audio visual setups. Hopefully that is a better audio quality. Testing, there we go. Okay, so to get back to the weather at hand, this is just a progression from the GFS model as to what this weekend system might look like as it comes in. And as I mentioned, it's going to be pretty cold for the time of year, nothing record-breaking. But as this swings through, and again, it's mostly going to affect Northern California and primarily on Saturday into Saturday night, that's a pretty robust late season system. This is not just sprinkles. This will be a pretty solid rain. It might even be briefly heavy at times with some briefly significant snow rates in the Sierra Nevada. You can see that cold core of the low moving in behind the initial cold front. The cold front's going to kind of wash out as it moves into Southern California. There could be some light showers or sprinkles down into Santa Barbara, Ventura counties, maybe some scattered showers farther south in Southern California, but it's possible that LA, for example, stays mostly dry. And if there is some rain down south, it'll be quite light. But it could be significant up in Northern California, along with some decent snowfall. This should be all done really by late Sunday morning, except some lingering showers in the Sierra, and that'll pretty much be the end of things. But just to emphasize the kind of precipitation totals that we're talking about, and again, this is from one model run, so I'll jump back to the ensemble to give you a better view of sort of the most likely accumulations. But this is from the GFS ensemble, so the American model ensemble, suggesting that total accumulations will be pretty decent along the north coast, the far north coast, and in the Sierra Nevada, where totals over an inch and maybe approaching 2 inches before all is said and done. Could occur this weekend in the Sierra. A decent chunk of that's going to be snow above 6,000 feet, so that could be a pretty decent late season snow accumulation. These are the two regions that are kind of favored for May precipitation generally. So from San Francisco southward along the coast, the typical precipitation in May starts to decrease substantially in the month of May. There's often a few showers, but nothing huge. You can still get some pretty substantial precipitation up along the north coast and the central and northern Sierra into May, and that's likely what we're going to see with that system this weekend. I jump over to the European ensemble, which is actually a little bit wetter, showing slightly more widespread, moderate, I guess I call it moderate precipitation, with maybe a half inch or a little more down into the Bay Area and even parts of the Central Valley. So again, likely to be a widespread soaking for places from about the San Francisco Bay Area northward, maybe a little farther south than that in the Sierra Nevada. Some precipitation possible in Southern California, but it'll be brief, light, and in some places it might not rain at all. So it'll be a cool late season system. Another little top up of the mountain snowpack. It'll get the ground wet, so further delay fire season in some spots. Probably and could have some agricultural impacts too for water sensitive crops, since it does look like it will rain in most of the Central Valley at some point on Saturday or Sunday. But other than that, nothing too hugely consequential. If I do take a glance at the atmospheric instability, zooming in a little bit more, looking at the convective energy with the system, this is this weekend. This is coming in again. I need to go all the way to Saturday afternoon into Sunday. There is a little bit of convective available potential energy as the cold core aloft swings through the San Francisco Bay Area and the Central Valley, but actually by the standard of many other storm systems this year, there's not a tremendous amount of atmospheric instability, so I wouldn't expect any severe thunderstorm activity with this one. There might be an isolated thunderstorm or two, but probably not super notable for thunderstorm potential. Although there will be some isolated storms probably up north when the cold core aloft moves through. Arguably another sort of net beneficial system that's going to deliver some water without delivering too many problems, to be quite honest, which is something that's nice to see. Especially since you never know when it's going to be the last meaningful system of the season. This time of year, it's always possible that it's the last substantial storm of the season in certain places. In some parts of California, particularly central and southern California, that storm may already have passed, the last meaningful precip of the season. In northern California, I wouldn't be surprised if there's another soaking in the mountains or up along the north coast at some point between now and June after the system, as would be climatologically favored in those regions. And we're certainly not seeing an indication of early ridging or heat waves still. So in the absence of that, there's always the potential that we continue to see these occasional weak to moderate and relatively cool spring systems. I guess it was April showers until today. Now it's May showers. If April showers bring May flowers, then I guess May showers maybe just delay fire season for a few more weeks and potentially keep fuel moisture conditions in a range that are favorable for prescribed fire treatments for a little bit longer. I know sometimes there are frustratingly strict calendar date cutoffs that are not very environmentally conditioned aware, so that's not always the case, but it does mean that from a fuels perspective, this will be another soaking, and I guess this isn't an official term, but season delaying rain for parts of Northern California. Every time you get a nice half-inch soaking over a widespread area and you don't follow it up with a big heat wave, it takes a while for that landscape level dryness to return to where it would have been without that delivery of convenient water at a particularly conducive time. So that's just about all I got to say about this weekend system. If we look ahead a little bit further, and for this I will go into the ensemble because it's always better to use model ensembles when you're looking farther into the future. This is what the European ensemble thinks for the geopotential height anomaly. So the blue areas are places where the mid-atmospheric low pressure is more prevalent. As we go through, we see that the western U.S. is sort of favored for general troughiness, a little bit of ridging over the Pacific Northwest, but as we go towards mid-May, not a super strong signal for much of any signal. At this point, maybe a slight weak trough over the west coast and a slight ridge over the eastern Rockies, but really this is not a super strong signal of anything. If we look at that's actually more recent, so ignore that for a moment. If we look at the American, the GFS ensemble, similar pattern, very weak trough on average across the west coast and weak ridge inland. So actually the models are in pretty good agreement about what things will look like heading toward mid-May, which is to say, in agreement that it probably doesn't look too extreme in either direction. It does look drier, though. The likelihood of these late season systems will probably decrease, as is consistent with what you'd usually expect as you go later in May. If we look at temperatures, we start off with a relatively high likelihood of cool temperatures over the next 5 to 7 days, or the next 5 to 10 days, really. And that sort of trends back towards near average temperatures by mid-May. Of course, mid-May is usually warmer than early May, so a trend towards near average conditions still means a warming trend as we go through May. But it looks like it continued to be cool along the coast. And in fact, as we go towards mid-May, this may be a signal of some classic May gray along the coast with relatively cooler temperatures along the central and southern California coast. So really a pretty benign outlook for the next couple of weeks, aside from this weekend system, which might disrupt your plans if you're trying to drive up I-80 into the mountains, some late season snow, and inevitably some chains on vehicles at pass level probably at some point there. And then Okay, now I want to talk about the bigger picture, and I'm also going to share some additional stuff on screen, some different things. So first we'll start with what the global oceans look like right now. And this picture is interesting for a few reasons. One is I want to reorient everybody that the reds and oranges, as you might expect intuitively, are places where the ocean temperatures are above average, and the blue splotches are places where the ocean temperatures are below average. There's essentially nowhere that's in the purples, so I won't even mention it. But what's interesting here is that this is, you see, first of all, that there's clearly a lot more orange and yellow than there is blue on this global map of ocean temperature anomalousness. But also, the striking piece in this is that this is relative to a relatively recent baseline. So this isn't saying that most of the global oceans are just warmer than they were during the 20th century, but this baseline is much more recent. This is a baseline from the past several decades. So what this is actually saying is a bit more extraordinary than it might appear at first glance. This is saying that almost all of the global oceans right now are significantly warmer even than the past few decades, which were already significantly warmer than the decades before that. So this is saying that on average, the global oceans are super warm right now in most places, relative even to the warming trend in recent years. So in other words, it's saying a lot. There is interesting spatial structure to this too, though, and there are some substantial things to look out for. One is that in general, the tropical oceans right now are extremely warm, with the singular exception of this cool blob that's developing in the eastern equatorial Pacific Ocean. And anybody who knows anything about ENSO, or the El Niño Southern Oscillation, knows where I'm going with this one. This is an early sign of the incipient La Niña, or the cooling of the eastern tropical Pacific Ocean temperatures. This was a region where temperatures were well above average until a couple of months ago, associated with a pretty strong El Niño event, but now we are actually seeing, consistent with predictions from coupled ocean and climate models, cooling of the eastern equatorial Pacific Ocean, and that's fairly substantial. So it's splotchy. You can see these interesting sort of mesoscale, essentially warm and cold fronts in the ocean, which are effectively ocean eddies, as this cool upwelling zone mixes with the warmer zone absent upwelling to the north. But overall, the important part is that there is some cool water developing in this eastern equatorial Pacific region near and west of the Galapagos Islands, west of Peru, and that's expected to expand greatly in the coming weeks and months. Notably, near the coast of Peru itself, though, it's actually still very warm. I do expect that to change soon. Also notable is that the western tropical Pacific Ocean is super, super warm. It seems like it never wants to not be warm anymore. La Niña or El Niño, that's always warm in the western tropical Pacific. That may be a theme heading into the next La Niña event, and it could be important for conditions in California next winter, but I'll revisit that at a later date. The other interesting thing is, again, there's some after a winter with elevated water temperatures along the west coast, and particularly near California, what we can see is that generally the northeastern Pacific Ocean is no longer warmer than average, and there is actually some cooler than average conditions showing up along much of the California coast, the Baja California coast, and again, this is relative to recent ocean temperatures. So this may actually still be warmer than the 20th century average, but this is cooler than the average over the past several decades, and that's certainly cooler than it was in relative terms compared to this winter in this region. So there has been cooling over the past several weeks in this region near and west of California. In fact, there are several blobs in the subtropics globally where the oceans are, I guess I'll call them, less warm than other regions. One is here off the coast of California and Mexico. The other is this relatively smaller area off the coast of the eastern coast of the U.S. This might not be super persistent, and this is a fairly recent development due to some storm activity. We also see some similar patterns emerging in other patches of the subtropics down here in the southern Indian Ocean, and here off the coast of South America, particularly the west coast of South America, but also to a lesser extent the east coast. I think what this is telling us is this is sort of El Nino's last gasp as we transition towards La Nina, and we should expect that these global ocean warmth anomaly patterns to shift considerably as we head into the summer. Now, nonetheless, we expect that almost all the global oceans will remain super warm, but I would expect this blue blob to expand greatly. One interesting way to test this, actually, is to compare this map, keep this image in your mind before I transition pages, because this is a climate model projection from about a month ago of what this map should look like right now. And honestly, it looks pretty good. We have these relatively cooler blobs in the subtropics that I mentioned, in the southern Indian Ocean, the southern Pacific Ocean, this broad region west of California. It's a little warmer near the California coast than it actually is right now, but overall, this region looks pretty good. This cool tongue developing along the equatorial Pacific that we were mentioning, as well as this relatively cooler area here in the subtropics. But I'm going to go back to the observed map right now. The other thing that's incredible is just how warm the tropical Atlantic Ocean is. I mean, look at this. There's really no area here that's less than 2C, or about 3.5 or so degrees Fahrenheit above average. And there's a lot of areas that are in the 2 to 3C range. So they're talking like 4 or 5 degrees Fahrenheit in some places above average. That is a very large temperature anomaly across such a wide region. And that extends into the Caribbean and the Gulf of Mexico to a certain extent. One reason I wanted to highlight that is because of what it means for tropical cyclone risk, in other words, hurricane risk, later this season. And the ocean here is on fire. And as we head into a year with La Nina, which tends to favor lower wind shear environment, which is favorable for tropical cyclone development, you couple that with what are still record or near record ocean surface temperatures in this region compared to every year except last year, which was, of course, the warmest year on record. This starts to ring some alarm bells in the hurricane risk world for the Caribbean and for both the Gulf Coast and the eastern seaboard of the United States in particular. But going back to this projection for what things might look like later this year, I'm going to zoom in a little bit. Maybe I can, maybe I can't, maybe I can't. Okay, well, anyway, I'm surprised that didn't work. Let me try one more thing. There we go. That actually did work. Okay, I just was pushing the wrong button. So I'm going to step through what this is the North American Multi-Model Ensemble. This is different than the modeling ensemble that I showed in the last session, although there is overlap between models, and you generally get the same idea from a global ocean temperature perspective, so I don't think it matters too much for the purposes today. But I want to step through a few things. This, again, is for April now. The global oceans are generally on fire, with a few exceptions of places in the subtropics where they're not, and that tropical cool tongue La Nina developing. Keep an eye in particular on that cool tongue off the west coast of South America. This is the prediction now for May, and boy, La Nina really looks like it might get going later this month. That is the prediction anyway, and I wouldn't be surprised if this ends up being true. Notice that the cool splotch in the Atlantic, the subtropical Atlantic, fills into above average temperatures once again, which is not good for hurricane season, and the Gulf of Mexico gets even warmer. But again, the subtropics in different places, particularly the northern and southern subtropical Pacific, probably consistent with the developing La Nina event and the effects that has on the Hadley circulation and that subtropical high pressure system. A region of not so above average temperatures and ocean surface conditions off western North America. The North American ensemble keeps some warmer water west of California. I wouldn't be too surprised if that goes away and there's a little bit more coolness coming up the coast as there is off of Baja. As we head into June, we'll see how that evolves. But what's really pronounced here is that La Nina in the multi-model ensemble is now clearly developing by June, so that's pretty early. And the polar opposite condition in the Atlantic, with the entire Atlantic once again being just absurdly warm, in fact even warmer relative to average than it is now. And again, you look at this map, how much blue is there relative to red and orange, and the answer is not much outside of the tropical Pacific. So we'll see potentially a historically unique combination as we go later into summer of global oceans that remain near or above even global record-breaking ocean temperatures everywhere but the tropical Pacific, where they might actually get really cool relative to average. This is indicative now we're in July of a pretty darn significant La Nina event. I mean, that's quite a signal developing already, and we see some of this cooler water, or at least near average, near shore water temperatures near California and Baja. But just about everywhere else, the Atlantic, the northwestern Pacific, the entire Indian Ocean, much of the South Pacific, and much of the South Atlantic, all much warmer than average. The Arctic, of course, by the time you get to later in summer, much warmer than average because of the fact that there is no longer sea ice where there once was, even just a few decades ago. Now we get into August, we see the same kind of signal. La Nina continues to strengthen, and this is starting to look like quite a robust event. It's sort of a pan-Pacific La Nina. We'll see if this is what the real world actually holds, but if this is the case, it's likely to exert a profound effect on global climate for the second half of 2024. The Atlantic remains on fire. We're now getting closer to the peak of hurricane season. This is not good news for anyone living in the Gulf Coast states, the Caribbean, or the eastern seaboard of the U.S., where the risk of tropical cyclone, and also, although it's somewhat less likely, the eastern coasts of Central America, the Gulf coasts of Central America, where hurricane landfalls can sometimes occur and be devastating when they do. There'll be a very elevated likelihood in the number of storms, and in particular the number of intense storms, because there's so much potential hurricane fuel in these warm oceans. I would not expect this year to be an elevated eastern Pacific hurricane season. So look at the relatively near to even slightly below average ocean temperatures in this region. I think this would make something like a Hurricane Hillary-like event. It's already a low likelihood in any given year, of course, as occurred last year. But last year was one of the kinds of years where we would expect to have an elevated likelihood of a remnant tropical cyclone getting close to or moving over California, as Hillary did, bringing record-breaking rainfall in August of 2023 to Southern California. It's still possible even during a La Nina year, but it would be even less likely than usual. So I think the likelihood of tropical storm remnant events in Southern California this year are, I guess you could say, below average, even though the average is already somewhat unlikely, but not impossible. Last year was above average, and we saw one. This year will likely be below average, and we probably won't see one, although it's always possible. But as we get into September, really what we see is just further amplification of this pattern that develops all summer, with an even more dramatic and blue blobby looking La Nina event. That is really striking, coupled with a super warm tropical western Pacific, super warm northwestern Pacific. This is downstream of the Kuroshio extension for those oceanographers out there, which something is going on here. It's been like this constantly in recent years, and there's an interesting element in climate models that suggests something similar might happen, so I think we're seeing that. But suffice it to say that come September, below average likelihood of major hurricane activity potentially in the eastern tropical Pacific Ocean, but a much above average likelihood still in the Atlantic Basin, and this is big news for places like the Gulf Coast of the U.S. and the Caribbean in particular. Meanwhile, the rest of the global oceans remain super, super warm outside of the tropical Pacific Ocean, and with this extension of not that super warm across the subtropical Pacific, including the coast of California. And so we continue to go forward in time. A classic strong La Nina pattern in the multi-model mean. I mean, this just continues to grow. I mean, we're sort of maxing out the color bar here at -4, -5 centigrade. As directly depicted, this would be a pretty heavy-duty La Nina event. And, you know, it's notable that there would be relative coolness that's pretty extreme near the equator and relative warmth in the Arctic that is extraordinary. What this would do, I mean, you can imagine that on average it's colder in the Arctic than it is in the tropics, so if it's cooler than average in the hot place and hotter than average in the cool place, you decrease your gradient between the tropics and the Arctic, and that can have some implications for large-scale climate conditions. But generally speaking, what I just want to emphasize is that we have this weakening of the SST gradient, the sea surface temperature gradient in the Pacific Ocean too, with very anomalously cold temperatures along the equator and very anomalously warm, now extending up into the Gulf of Alaska. California is downstream of this, and this can affect the jet stream and would probably start to favor, along with this warm blob in the western Pacific Ocean, which we know through complicated teleconnections known as semi-persistent Rossby wave trains, which arise through waves in the atmosphere that are essentially emanate outward from clusters of deep tropical thunderstorms. It's a bit of an advanced topic for today's conversation, but suffice it to say, this is a pretty striking map. Sometimes we see a map that's, generally warmer than average because of global warming, but kind of spatially homogeneous. This is anything but, and this is a projection for this is sort of what next September and October look fairly similar as I toggle back and forth between them. If we see this, we will likely see an autumn dominated by extremely warm global temperatures overall, but a rather strong and still intensifying La Niña event in the Pacific with super warm temperatures in the extratropical North Pacific and potential record warmth in the Arctic. That's a complicated picture, and as I mentioned, as we head into winter, I think this is going to be a major influence. And I talked last time about what this might look like in terms of precipitation and temperature across North America, and I'll just reemphasize that there is an elevated likelihood of a weak monsoon this year in the desert Southwest, so lower than average precipitation possible in places like Arizona and New Mexico during the peak monsoon season, and maybe bleeding over into adjacent states, including the southeastern desert portion of California and Utah and Colorado to the north. But the more consequential piece of this is I actually think that there's likely to be considerable continental heat waves in the extratropics. So ironically, cooling in the equatorial Pacific actually often leads to hotter summers in the mid-latitudes, and that does include the interior parts of California as well as most of continental North America. So I would not be surprised if this was a very hot summer across the continental interior of North America. What this means is that there may be, and I'm actually going to switch back so you see my face again, since I think I'm done looking at the maps for now, and we'll take questions in a moment. What this might look like in terms of the fire season is, given what we've already seen in California, for example, I still think we're going to see a late start to the fire season in most places and a weak start to the fire season. So, in other words, good news, fairly benign, wider windows for prescribed fire and other kinds of treatments because the crews won't be busy working on other things, hopefully. I know it doesn't work that way in the real world in practice, but I don't think there'll be a particularly early or busy first half of the season, so looking at May, June, even July in much of California. I did mention last time why I think the desert fire season in June and July might be a little bit more robust and start earlier, so it's a little bit of an outlier. We don't usually think about the deserts in California and the Southwest as being particularly wildfire prone, but they can be under the right sets of conditions, particularly in hot summers that follow wet winters, because in the wet winters you have the vegetation growth to fill in the gaps in sparsely vegetated areas, and then you have the hot summer to dry it out. I do think we'll see that this year, so it's possible there'll be some earlier season fires in places really from Joshua Tree eastward, and those can be disruptive because not all of these ecosystems are adapted to fire in the same way that many other Western ecosystems are. Just a heads up, but in general, overall, I would expect the risk of dangerous wildfires or very large wildfires in California to be quite low, at least for the next 2 months and maybe the next 3 months, even into July. But I also don't think that's going to continue, and I think that there could be a pretty dramatic reversal sometime during August or September in California, where we start seeing pretty major heat waves and the residual moisture from this wet and cool winter, well, not so much a cool winter, but at least a wet winter and mild spring, I'll call it that, has mostly gone away, and there are strong indications that potentially record-breaking mid-continental heat will spread westward later in August and September, and potentially dry things out to the point where we see a very rapid escalation in fire season right around when fire season tends to peak in California, right when there's the highest likelihood of offshore winds. and in a year where there may be an elevated likelihood of a delayed start to rainy season in the fall. So all of that may come together. It's difficult to foresee the future, even though that's the business we're in. But I do think that there's a tilt in the odds toward a fire season that will be unusually mild to start in California and near or above average severity in its final month or two. And that tends to set the stage for people who are very surprised when fire season rapidly escalates and when we see potentially dangerous wind-driven fire conditions in, say, September or October. If we don't get those early season rains, but we do have those traditional offshore winds in autumn, and we have a particularly hot period, an unusually hot potential for August and September and October, where the delayed rainy season would result in probably a very active fire season, as discussed last time, because we had a lot of vegetation growth and not a lot of area burned in the last few years. We're due for a pretty substantial upsurge in wildfire activity if and when things do dry out and warm up. And I think there's a good chance that precisely that will happen later this year, starting probably in August or September. So that's the California perspective. As I mentioned, we're already going to potentially be off to a roaring start in New Mexico and parts of Arizona fire season as soon as this week. They do tend to have an earlier fire season there, and they're already experiencing a severe drought there that is likely to get worse this summer due to high likelihood of very high temperatures, unusually hot temperatures even by the standards of Arizona and New Mexico, along with at least a tilt in the odds towards a weak monsoon and a warm autumn to follow. So there could be some big-time fires in New Mexico and Arizona in the coming weeks. And then across the northern Rockies and up into Canada, another severe drought region, and I would not be surprised to see an early start to fire season in western Canada and the northern Rockies, and then maybe an intermediate kind of start, maybe more similar to California in places like Colorado, where it might start off relatively mild. It's been pretty wet with a good snowpack, but with a very high likelihood of quite a hot summer, much hotter than average summer, that will probably dry out to the point where we do start seeing elevated fire activity, potentially above average, by the end of the season, once that unusual, anomalous, potentially record-breaking summer heat acts on all of that extra vegetation that has grown in the last few relatively wet years. And Canada stands likely to see another severe fire season. By the way, folks have asked, do I think Canada will see as bad a fire season this year as last year? The answer is very likely no, but that is only because last year broke records by such an insane margin that even doubling the previous records from every year prior to 2023 would be a historically severe fire season, but for last year, but would end up falling 80% behind last year. So point being, I think it's unlikely that this year will break last year's Canadian fire records, even though I think there's a chance that this year could be so active in Canada that it might still break records for any year prior to last year. So it will be very high likelihood of having a very active fire season in Canada relative to almost any other year in recent history, except for last year, which was just so almost inconceivably extreme in terms of area burned that it's unlikely that we would exceed it. The real world has had a way of testing predictions like that recently in ways that are a little bit scary, so we'll see if that holds. Again, just to reemphasize, I do expect an extremely active fire season in Western Canada, even though it'll be hard to top last year. What else? And I think, that's the big picture. I did mention the Atlantic hurricane season, and this year there's a recipe for an incredibly active hurricane season. Some research groups that create seasonal predictions of hurricane risk are explicitly predicting the most active season on record. So often these groups are somewhat conservative in predictions, and they're seeing conditions that align so extremely with an active season in the Atlantic basin that they are predicting at or near record-breaking levels. That's saying a lot, and I don't really see any reason to doubt those predictions, given that the ocean surface temperatures, both in the main development region, so in the eastern Atlantic, as well as the more proximal development region for hurricanes in the Caribbean and the Gulf are all well above average and expected to stay well above average and potentially warm even farther above average this summer, coupled with the transition from El Nino to La Nina. So we had record-breaking warmth last year in the tropical Pacific, but we had El Nino conditions, which usually means relatively unfavorable wind shear conditions for hurricanes in the Atlantic. So we had the high maximum potential intensity ceiling due to the warm oceans, but we also had a pretty low unfavorable environment due to atmospheric wind shear from El Nino. But this year, we're likely to still have that extremely high ceiling on intensity, and now we're going to see a potentially strong La Nina by mid-late summer, which now raises the ceiling on the sort of the genesis potential for hurricanes. So that means we'll have not only near to record-breaking ocean warmth and hurricane fuel, because warm tropical oceans are hurricane fuel, but also an environment that's favorable now, unlike last year, for those storms to actually develop in the first place. So we have both the fuel needed and a higher likelihood of the sparks to generate those systems in the first place. So yeah, it's I have a feeling that this year there's going to be major headlines about hurricanes in August and September, potentially in other months as well. So, we get this picture of a fire season in the United States, and again, I focus mainly on the Western U.S. because it's where we usually talk about fire season, as well as Western Canada. There is, of course, a fire season in other parts of the country as well. That's a little bit less dictated by El Nino and La Nina type transitions. I can talk about those a little bit later, but I wanted to focus on the western part of the continent in terms of wildfire, and the eastern part of the continent in terms of hurricane risk. And this year stands out as being a potentially exceptional year from a hurricane risk perspective, and an unusual year from a wildfire perspective, in the sense that we might see a season that starts slow in some places but actually becomes quite intense later in the season. And so don't let your guard down, but also enjoy the next few months of relative calm. The other piece in this is, as I mentioned, all of this is occurring amid the transition from El Nino, which means warm temperatures in the eastern equatorial Pacific Ocean, to La Nina, which means cool temperatures in the eastern equatorial Pacific Ocean. And that transition, historically, usually means that global temperatures start to level out or even decrease a little bit. So you may recall that in recent discussions I've talked about why the whole world just seems to be so ridiculously warm right now and in recent months, and why the past 12 months are by far the warmest on record, and what that means in the context of 1.5 degree temperature targets and things like that. But the reality is that there is some natural variability in the system where El Nino tends to result in a bit more global warmth, so on the order of like 1/10 of a degree or so, and La Nina does the opposite, a bit cooler on the order of 1/10 of a degree or so. So the reason I bring this up is the Earth remains, even right now, even warmer than it was last year, so breaking even the extraordinary temperature records set just a year ago. Now, it's breaking them by a narrower margin than it did last year, but I don't know, that's still a pretty alarming number in my book, because it means that we shattered records last year, and then this year we're still breaking the shattered record from just last year. So again, that's actually more impressive and more alarming than it sounds at first glance. But what I do believe is that over the coming 6 months or so, that these temperatures will likely level off and we will stop continuously breaking records as we transition to La Nina, and some of this energy starts to get sequestered into the tropical oceans. It doesn't mean that the additional energy from global warming is going away. It just means that it's getting temporarily sequestered preferentially in the global oceans again to become unearthed again the next time we have a big El Nino event. So it's not really solving any problems, but it does mean that I do think that global temperatures should level off in the coming months, and maybe even decrease a bit. Cue all these misleading blog posts about social media posts about how the global cooling between 2023 and 2025. I will not be surprised if there is a flurry of look, the Earth is cooler in 2025 than it was in 2023 when we shattered all records. And then those we'll stop seeing them again in 2026 or 2027 when the next El Nino event comes and we have yet another record warm year. That's the way I tend to think about these things. Now, that is a bit of a prediction, maybe even a little bit of a glib one, given the consequences and the stakes involved. But I do think that it's pretty likely that we will stop seeing this continuous run of all-time record-shattering type extremes, and maybe that will bring down some of the rhetoric regarding how climate models got it wrong, which they didn't, or how we have absolutely no idea why the Earth is as warm as it is right now, which we certainly do, and that somehow the Earth is experiencing runaway warming in a way that was completely different than predicted, which we're not. I think that maybe this will help us recalibrate some public expectations in that respect. Now, there's a caveat here, which is that is an assumption. It is an assumption that is based on science and modeling and process and theory that these global temperatures should eventually, later this year and going into 2025, level off or even cool a little bit globally. And that's mainly because of La Niña, because of course global warming hasn't gone anywhere. Both the effect of greenhouse gases and the decreasing mitigating effect of those solar radiation reflecting aerosols are both going to continue to be there and get even a little bit stronger, year on year. It still is growing in effect, but mainly because of that natural variability that we get from a potentially strong La Niña event that should exert some temporarily global cooling. It doesn't really get rid of energy in the system, of course, it just sequesters it in the ocean to come back out and haunt us later. But from a global temperature perspective, that is what I would expect to see. Now, the caveat is if that does not happen, if 6 months, 12 months from now, we're still talking about continuing to break temperature records set in 2023 and 2024, then as other climate scientists have mentioned and acknowledged, and then I think then that would require a reevaluation of exactly what's going on, and it would be pretty concerning. But I think the general expectation among ocean and climate scientists right now is this is probably where we're headed. We're about to level off, and likely we'll be a little bit cooler in 2025 than we were in either 2023 or in 2024. And we'll probably drop back down below that 1.5 C number. If we don't, though, you'll hear it from me directly, and we'll have to explore what that means at that point. And there will be a lot to talk about. There'll be a lot to talk about either way. We can talk about why it happened as predicted, if it does, and we can also talk about the implications if it doesn't. And so, that's the thing about science is that you make predictions, and hopefully you're right more often than through random guessing. Usually you make them when you're supported by process-based modeling or theory, and sometimes you're right and sometimes you're wrong, and hopefully you're right more often than you're wrong. But when you're wrong, sometimes it makes sense to take a step back and consider why and what the implications of that are. And this is different than being wrong about a weather forecast because on very small spatial scales and with individual weather events that are chaotic in the atmosphere, sometimes you can get it wrong just because, you got unlucky, random chance. But when we're talking about global average temperatures over multiple years, that's a little bit less true because there's a lot of smoothing involved, there's a lot more Earth system inertia involved, if you will. And so we really should see some of these effects if they're operating as we currently understand them in a way that's consistent with how we currently understand them anyway. So putting that out there, and you can refer to this May 1st, 2024 session in 6 to 12 months from now when we have that discussion about what happened. So stay tuned for that one. But it does look like we're headed for a major La Niña event. It does look like that's going to affect things like hurricane season this year in the Atlantic, which could be supercharged given the context of record-breaking ocean warmth plus a strong La Niña potentially. It could mean a heavily back-weighted fire season in places like California as we transition from cool and wet, or at least mild and wet, to potentially dry and unusually warm once again by fall. And it may affect next winter and the prospects of the Southwest drought re-intensifying. Of course, California is really not experiencing a drought at all right now, so there isn't really a drought to re-intensify in California, but there is more broadly in the Colorado River Basin. California always has been a little bit on the margin of that multi-decadal mega drought. Been some recent news headlines that last winter ended the California mega drought, which is a little weird because California wasn't experiencing one to begin with, so with a little bit less dramatic, what actually happened is that the last big winter, 2023, ended the definitely severe and even extreme, in some cases, drought, but not really a multi-decadal drought because, frankly, it's hard to get those in California because there is so much variability of precipitation from year to year. We can quickly get into droughts faster than in many places in the world, but it's also a little bit faster to get out of them because sometimes all it takes is one really wet year to alleviate most of those drought impacts, as we've seen recently. One other point, as I take a sip of tea, one other point is that there was a study that came out last week. I made some comments in some news media articles. Journalists had asked me to review a confidential copy before it came out, and then the paper was publicly released this week along with the news coverage of it, focused on the really incredibly snowy winter last year in California. And I think it's an interesting paper. It's written by some of my colleagues at UCLA. I was not involved with it, but I did review it prior to making comments on it for journalists. One interesting piece is that the cold temperatures last winter in California were genuinely kind of jarringly cold by recent standards. They were the coldest temperatures last winter in decades in California, which is, of course, at great odds with what was going on in the rest of the world, experiencing record-shattering warmth contemporaneously. So California was an incredible outlier. Still not record cold, though. In fact, if you go back to the early 20th century, winter 2023 temperature-wise would have been not that remarkable. You would have gotten cold temperatures that cold every 5 or 10 years. But in the last several decades, we haven't seen temperatures that cold at all until last winter. And what's interesting is that if in this study, and this I think was a little bit buried in the study findings, and I'm not sure that as many journalists picked up on this, is that the best estimate by the study authors as to how likely temperatures as cold as observed last year in California during winter are in the present climate, so the climate of the past few decades, which of course is a much warmer climate than that of the early 20th century when such temperatures occurred somewhat regularly, was about 1 in 600 years. That's a big number, and it means, and this is what the basis for statement that I made, is that I personally don't expect to see a winter as cold as last year ever again the rest of my life in California. And a lot of folks are really surprised to hear this, but that's exactly what is implied by the recent climate interval suggesting that a winter as cold as last year statistically is like a 1 in 600 year event. Again, recurrence intervals do not mean that it occurs every 600 years on some recurring cycle. It just means that there is a 1 divided by 600, so a very low chance that it happens in any given year. And clearly, in the early 20th century, the odds were way higher than that because we actually saw winters that cold several times. So clearly it wasn't a 600-year event, it was probably more like a 6-year event. Maybe a 10 or 20-year event, but certainly not a multi-centennial one. So we've gone from something that would have been maybe a 10 or 20-year recurrence interval event, something that the average person would experience multiple times in their lifetime, to something that, frankly, I don't think we're likely to ever experience again. So 2023 was an extreme cold outlier in terms of California winter in the recent climate, but not an extreme outlier in the context of the much cooler early 20th century climate. And that's just an illustration of how much things have changed, I think. And, you know, the statement about me believing that it's unlikely I'll ever personally experience, or anybody reading this article or listening to this YouTube talk will ever experience a winter that cold again, is simply a reflection of the fact that I don't anticipate, for better or for worse, living more than 600 years. And I don't think it's likely that anybody else will either. It's really just that simple. So that's the quantitative basis for that one. And by the way, with further warming, which we're going to see, the odds will increase even further. There'll be even greater odds of that this is the kind of winter that, at least in terms of temperature, that I'll never experience again, and you'll never experience again, and probably no one you ever will meet will ever experience again in terms of how cold it was. Because with an extra 0.51 C of warming, which is very much within the path that we're on, that 600-year event could well become a 2,000-year event or a 5,000-year event. I mean, effectively, it means it ain't going to happen again, in all likelihood. Is there a 100% chance there? No. Is there a range on the uncertainty and how rare of an event it was in this climate? Yes, and the authors put uncertainty bounds. I think it was something like a 200 to a 1,200-year event. But even then, do I expect to live 200 years, and do I expect there to be no additional warming? The answer is no to both of those questions. So my statement still holds. I don't expect to live more than 200 years, so probably won't see it again. That's a very different statement, though, than saying, I don't think that there will ever be a winter that wet again in California. In fact, that's the exact opposite of what I expect. I expect that we'll see greater likelihood of winters as wet, or even wetter than last winter. That's what every indication is in the climate model world, is that we will see more extremely wet years in the future. And there's some uncertainty about the degree to which the magnitude of those changes, but in general, I would expect there to be wetter winters more often than drier winters in the future. Now, we will still see super dry winters, and we may even see some years that are even drier than we've seen historically. Even the extreme drought years may even get more extreme, but the extreme wet years will probably get more extreme at an increasing rate than the extreme dry years will get increasingly dry. So, will we see a winter as cold as last year again in my lifetime? Almost certainly not. Will we see a winter as wet as last winter in my lifetime? Almost certainly yes. In fact, the odds are going to get progressively higher with each passing degree of warming that we see a winter as wet or wetter than last year. And of course, that's exactly what you'd expect in a climate where we see increasing swings between extreme wet and extreme dry and warmer temperatures overall. The really cold years become vanishingly unlikely, but both the really dry years and the really wet years both become more likely in the same regime. Although, I think, and this has gone a little bit under the radar, there's more evidence that the really wet years increase faster than the really dry years. So, I actually think that we'll see a winter as wet as 2023 or wetter sooner rather than later. And it may not come so evenly distributed. We got lucky last year that the precipitation didn't come all at once. It was actually pretty distributed throughout the season. It was that never-ending storm train, but thank God it was, rather than one incredibly intense month of precipitation, all jammed together. That's closer to the arc storm scenario that I've talked about before. We didn't get that, and I'm glad we didn't. But we will someday, and the odds are rising in a warming climate, even though I don't think we'll see as extreme of a snow event as we saw last year. Now, what's interesting is that the same study that looked at this, how rare the temperature anomaly was last winter, also looked at how they call them snow deluges. So these really snowy years that are greatly snowier than the multi-decadal average. So like essentially snow accumulations with about 20-year recurrence intervals. And what they found is that although the odds do decrease significantly in a warming climate, just as you'd expect, and they decrease less than average snowfall. And this is a point that I have made earlier, and they actually are able to quantitatively demonstrate this now, which is that average snowpack is decreasing faster than extreme snowpack, which really means that the variability of snowpack is likely to increase in a warming climate, mainly because the super low snowpack years increase rapidly and the super high snowpack years decrease more slowly. Now, to be clear, they both decrease, so the odds of seeing a winter as snowy as last winter are also decreasing with time. but they aren't decreasing nearly as fast as the odds of seeing a super cold winter. And they aren't also decreasing as quickly as the mean snowpack is. And this is likely due to the competing effects of warming temperatures on the thermodynamics of snow. As I've mentioned before, the obvious effect, of course, as it gets warmer, that you're more often on the wrong side of the freezing line. You're above freezing, and so precipitation falls as liquid rain rather than as snow. But also, in a warming climate, we do tend to see about 7% per degree centigrade or 3 to 4% per degree Fahrenheit increase in the atmosphere's ability to hold water vapor. And so there is more moisture available to fall as snow if it's cold enough for precipitation to be snow rather than rain. So between those competing effects, the direct thermodynamic effect of warming putting us on the wrong side of the freezing line is what wins out on average. So that's why we see such rapid declines in average snowpack, and why we still ultimately see a decline even in the big snow years too. But it also explains why we see a slower decrease in the most extreme snow events, because increasingly in the future, those extreme snow events are not driven by extremely cold temperatures, but by extremely high precipitation and temperatures that are just barely cold enough to fall as snow. So this is consistent with that notion of increasing snow whiplash as temperatures warm and as precipitation variability potentially increases as well. So just some perspectives on that study that I thought were interesting. There's actually a lot in it that if you read beyond the headlines. Anyway, that's often the case. All right, I'm going to quickly look at the questions. There aren't too many, and then I'll call it a day since we're past the hour. A question from Frank that I'm going to defer to a later date is, are heat waves getting more humid in California? And the answer is nuanced, and the answer is not totally clear because it actually depends a bit on whether we're talking about the coast or the deserts. I'll have a longer conversation on that at some future point. I need to do a little bit more reading before I'm confident giving a clear answer on that. I don't think we have a really clear answer actually, or consensus in the literature yet anyway, but I would like to do a little bit more reading. Ron asks, I think this is in reference to the autumn heat I was talking about in the seasonal projections, could these heat waves extend into early winter, December or beyond? Sometimes that does happen in Southern California. You can get heat waves even in winter in coastal Southern California, and to a lesser extent along the coast of Northern California, at least into November. There may be an elevated chance of that this year relative to usual. It's a little bit speculative, but and probably not December, but could they extend later into autumn than usual because we probably won't see an early start to the rainy season this year? That certainly seems possible. Bill asks a question that he explicitly mentions this for another time. How do you feel about coastal hardening as a response to recent rising waters? That probably is a question for another time. It might actually be interesting to talk about coastal issues and sea level rise in a dedicated session at some point. So again, I am trying to grow the audience on this channel and maybe have slightly more structured and more consistently scheduled sessions, depending on how a few things go. So I have some potentially exciting developments, but again, these remain in limbo, and I've learned not to trust anything until the documents are signed and everything's in writing. So I don't have that yet, so that's about all I'm going to say for now. All right, well, I think that's about it for the day. We're already past the hour, so thanks for sticking with me. Again, a late season cool system in Northern California this weekend. If you're going up to the mountains, expect snow, like some late season snow. Nothing extreme, but potentially disruptive if you aren't planning for it. And a good soaking across most of Northern California, potentially including the Bay Area and a good portion of the Central Valley too. So a further damper on fire season, which is nice, and a bit of a top up on the quite respectable snowpack that we've already got up there. So, all right, I'll see you all hopefully next week at a time TBD, but subscribe to get notified, or I now post announcements in 4 places, on Twitter or X, on Blue Sky, on Threads, which is shared to the Fediverse, so you should be able to see it on Mastodon, as well as in the Weather West blog comments section. All right, thanks everybody, and see you next time.